we can reduce the requirement for heat in the Northeast by 75 or 80% compared to an average new construction building.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast.
Welcome to the Passive House podcast. I'm Zach Semke, co-host of the Passive House podcast, and I'm very happy to have Mary James here joining us today. How are you, Mary?
I'm good. It's winter definitely here, but looking forward to California, more California winters coming soon.
Yeah, you've been enjoying some Seattle weather. Yeah, you've been enjoying some Seattle weather the last couple of weeks, it sounds like.
Definitely.
Yeah, and we are missing Matthew today, our co-host from Auckland, New Zealand, but we look forward to having Matthew back next week. A really great interview that you share with us today with James Petersen, based in Boston, Massachusetts, and looking forward to diving into that real quick here. But before we do, I want to take just a moment to thank the fine organizations that make our work possible here at Passive House Podcast and at Passive House Accelerator. A special thank you to Intelligent Membranes for being our sponsor of the week and making all of our work happen here this week. Also, thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks too to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thank you to our champion sponsors, Bewizo, Cascadia Windows and Doors, European Architectural Supply, Thacro, Icon Windows and Doors, Intelligent Membranes, LG Air Conditioning Technologies, and Source 2050. So, Mary, you spoke with James Petersen, and James is in the epicenter of Passive House practice right now in Boston, Massachusetts. And I think you do a great kind of introduction of James and the scale of work that he's doing and his firm is doing. He's at the center of all sorts of work there. As folks who have been listening to the Passive House podcast will know, Massachusetts is really leading the way in the United States, and I think you could argue globally, with Passive House adoption, thanks to some real great tailwinds they've got going now with some policy, both incentives to do Passive House as well as Passive House becoming required in code in many jurisdictions across the state. So that's kind of the context for this interview that why don't we dive into?
Yeah, let's go. Welcome to the Passive House podcast. I'm Mary James, and I'm here today with James Petersen, founder and principal of Petersen Engineering, which works primarily in Massachusetts and also throughout the Northeast. Welcome, James.
Thank you, Mary.
So I was really impressed looking at your website to see that you have worked on 69 Passive House projects. That's huge. And drilling down a little bit, 19 of those have been certified and 28 are design certified. And that includes more than 5,000 dwelling units. That's very impressive figures right there. So you must have gotten involved in Passive House fairly early to have been involved in so many projects. What was it that inspired you to do that?
Yeah, we've been very busy, and it's been for quite a while. So how we got there was that we were already doing Passive House like projects before Passive House. So it was a natural evolution that when the Passive House program came along, that we were well suited. All the basic tenets of Passive House were things that we were already doing, and had developed expertise in and fit with our technical values. Focusing first on what we can do to reduce heating and cooling loads in buildings, and then secondarily finding heating and cooling methods to respond to the enclosure. So that led us to have kind of an unusual approach as a mechanical engineer, which was understanding how enclosures work so we could participate in that optimization process. So working on projects in that way goes all the way back 25 years ago to the early 2000s. So as things evolved and Passive House came on the scene, it was just a nice fit for our skill set.
That's great. And did you get into mechanical engineering with a idea already that you were interested in efficiency and sustainability, or how did that evolve?
Yeah, so because I, for no other reason than familiarity, because my father was a mechanical engineer, that's the major I chose, and I got a degree in mechanical engineering. I didn't know anything about buildings, and my job out of college was in buildings, and that's how I've ended up in buildings. And I think what got me interested in energy efficiency was just kind of a core value of mine to want to do things well. So it was more of and mostly this is in retrospect too, it's just understanding that if I'm going to do something, I want to do it well. And so, reducing heating and cooling loads and taking a holistic approach is how to do a building well.
Well, I certainly agree with that. So just now going to present day, can you tell us a little bit about what percentage of your projects, of your firm's projects, are multifamily, large multifamily, commercial, institutional? Just give us a sense of what your firm specializes in.
Sure. So first of all, we are an MEP/FP firm. So we handle all the building systems, electrical, plumbing, fire protection, HVAC, and technology. So that's pretty normal in the industry that our clients can expect us to carry that full range of services. In terms of Passive House projects, because of what's been available to work on in Massachusetts, the vast majority of our Passive House projects are multifamily. And most of those have been affordable because it's that marketplace that developed in Massachusetts. So it's been relatively recently, say the last 5 years, that we've done some market rate projects. And then outside of housing, I'm thinking of one project that was a corporate retreat center. But I would say with the exception of one or two projects, they've all been multifamily residential. And they generally range, 75 units. We've had some smaller projects, but generally 75 to 200. The minimum for us, I think in our experience of those 69 or 70 projects have been, just a few of them have been less than 75 and a few have been more than 200. But that's kind of the sweet spot of large multifamily in Massachusetts.
And it's interesting to hear you say that you started doing more you're starting to do more market rate in the last 5 years, because my understanding of the Massachusetts passive house market is that it's spreading from affordable housing into other market rate projects. And are you seeing, I'm just curious whether it's presenting different situations to you to be working on market rate systems, MEP systems and fire protection, or if it's pretty much a continuum from the affordable housing situations.
It's different. So the way affordable started was that in the competition to be awarded affordable projects, the state incentivized developers to consider or to commit to Passive House. And that wasn't much of a stretch for affordable developers and owners because it was in line with their mission. The mission being providing housing for people who otherwise may not be able to afford it. So responding to the environment wasn't really a stretch in that sort of mission. And market rate, people are doing it because they have to. It's a code requirement, or which it is the case now in Massachusetts and many communities. And in Boston, it was, there was a real priority placed on developments strongly considering passive house in order to get through the approval process, the permitting process. And then we've seen a little additional extension. We're doing a very large higher ed dormitory to passive house. Well, it's passive house certified, and the motivation there is, getting on board with decarbonization and not just kind of with lip service, but actually doing it. So we're seeing an increase of interest in higher ed as well at this time.
Oh, that's great. And so one of your specialties, I think it's fair to say, would be electrifying domestic hot water services. Is that correct?
It is.
And that's been a harder nut to crack, really, for larger buildings. Can we just talk generally about what are the options and why it's been harder to tackle that than, say, heating and cooling?
Yeah, it has been harder. So just to summarize heating and cooling and how that worked, and because in my head I've been searching for analogies between heating and cooling and decarbonization, and what's the equivalent, what's the equal of that in domestic hot water heating. So starting with heating and cooling first, is the pathway became very clear. If we could suppress or decrease the need for heating energy substantially, we could provide heating in buildings that was affordable with electricity. So in very general terms, if we do a good job with the building shape, its simplicity in terms of its enclosure, it's the air barrier, the thermal barrier. If we can do a good job with all of that, we can reduce the requirement for heat in the Northeast by 75 or 80% compared to an average new construction building. So the way that stacks up with electricity is because of the cost of electricity. If we can take care of business with reducing the requirement for heat, then we can have a cost of heating that's acceptable, and that the owner doesn't have to accept a higher cost of heating. So that's been successful. Also with heating and cooling, the technology, we're already using the technology of air source heat pumps, and they're really good systems. They're high quality. They have been installed in Asia already, so they're proven technology. They were quiet, and the method of distribution of energy in the building was through the smallest pipe possible, which was refrigerant pipe. So there are reasons why it just fit really nicely. And even though there was some unfamiliarity with air source heat pumps early on, we knew that it was ultimately going to be an affordable system for first cost. And that I already described why it's acceptable in terms of operating costs. So that's the picture with heating and cooling. And with domestic hot water, we did a lot of head scratching on how we could have that be relatively seamless and a smooth transition. So I can move into that if you'd like.
Yes, let's talk more specifically about what are the options for larger buildings.
Right, for domestic hot water. So thinking of what I just described for heating, because cooling was already electrified, is what we have with cooling is we can't change the temperature at which a shower is comfortable. So that's a fixed number. So we look at so next we look at, okay, what is the temperature that we need to heat the water from? And can we do anything to reduce that temperature rise required to have a comfortable shower? So, for example, in Massachusetts, the water in eastern Massachusetts comes from a reservoir. And in the winter, it comes in at about 40 degrees. And in the summer, it peaks at about 75. So in the summer, we only have to do half the work to raise it to shower temperature compared to in the winter. So what are the opportunities to decrease that rise in temperature? That's one way of looking at it. The other way is, what are the technologies available to get that temperature rise most efficiently and most cost effectively in terms of first cost? That second option, that second question, what are those technologies? That hasn't been as ready and clear as it was for heating buildings. And the air source heat pump technology wasn't readily available. It didn't have a lot of history already somewhere else in the world, and we were starting at a disadvantage there. In terms of reducing the delta T, as we call it, there's a few well-established technologies, but are not implemented largely. And one is solar thermal pre-tempering. We know how to do that. We've known for years or decades. And then the other is recovering drain water heat, and essentially recycling the heat, not the water, but recycling the heat associated with that work that we had done to produce that warm shower in the first place. So that's kind of like that's kind of the landscape, if you will.
So let's talk about solar thermal first, because this is a technology that has been around so long, and it kind of, in my view of it, has had popular moments and then fallen out of favor. And for, more recently, people have said, no, just put on PV, and then, that's more cost effective because it takes care of providing electricity for a bunch of uses, but one of which can also be providing domestic hot water. So can you talk to me about why you see solar thermal as providing an advantage, and in which situations?
Sure. So 25 years ago, solar thermal was something that we built expertise in, and we incorporated into projects. But then it did fall, as you suggest, into what I would call, it fell out of favor. PV was viewed as kind of a plug and play, and we didn't want to steal roof space that could otherwise be occupied by PV. Solar thermal is got a mechanical component, which means it has to be serviced and maintained and monitored. So it's viewed as more complex and less likely to be successful, because it's more, by almost inherently, if it's more complicated, it's a greater risk that it's not going to work well. So we played along with that, and our projects ended up having PV and not having solar thermal. But in understanding and with the head scratching in how do we reduce this delta T, we reconsidered solar thermal after many years of dropping it. Also, the incentives for PV were well established, and the incentives for solar thermal fell by the wayside. So that was lost. So what we've done is we've looked at being very economical in how much area we take up with a solar thermal collector, and doing as much work, in other words, capturing as much energy from the sun as possible, but optimizing it. And when we can do that is in the months between, March 20th and September 20th, when we have a lot of sunlight and the sun's high in the sky. And when the sun's high in the sky, obviously we can collect a lot of energy. And when the sun's not, we should just throw those months out primarily, because your array gets large when you're trying to collect a lot of sunlight from just a little bit of sun. So we look at the opportunity there as let's meet the summer load with solar and see what the size of that array is, and keep it as modest as we can so we don't take up too much roof space, and also keep the cost of that down. And then also look at the technology really carefully, see who's been doing it continuously, and what are the tricks that they've learned over time to keep it as simple as possible so we have the best chance of that installation being successful.
Very interesting, because one of the advantages of solar thermal that I understand is that those systems, once you do put them in place, they're very long lasting. I mean, they're, from what I've understood, they can keep going for years, and sure, they require some maintenance, but I'm curious whether, when you say you're only thinking about using them during the summer months, which of course, cuts, or not summer months, sorry, from March to September, that can cut a significant chunk of your water heating energy use. Does that mean that you would maybe have a drain back system that you turn off during the winter months so you don't have to worry about freezing?
Yes, it's not a hard cutoff. Having 12 hours or more of sun is just kind of a rule of thumb that we have. The sun's high and it's out for a while, and the atmosphere tends to be more clear than it is, say, November, December, January. So those are good thermal energy collection months. But drain back, you mentioned drain back, and our colleagues that have been doing this work for years, drain back is simplest. So we can be very careful and have a good drain back system. And that does give us the flexibility of, the sun, the sun in February is as high as the sun in October. So there is energy to be harvested there. February is still cold in the Northeast. So a drain back system can work really well. And the system is automatic. So we don't decide to not collect in February. We let the system decide whether it's good for collecting energy. We're just aware that the amount of energy that we can collect in February is a lot different than the amount we can collect in June.
Great. And so have clients been receptive to solar thermal?
It's been a slog. No. A lot of times what we run into is, and I mentioned familiarity when we introduce and we're advocating for air source heat pumps for heating and cooling. So we're running into the same issues anytime we introduce anything that's a change or anything that's new. So, but we're used to the fight may be too strong a word, but we're used to that. It requires some patience and some persistence for something to be implemented and to get past the familiarity challenges with estimating and contractors and owners accepting it and implementing it. So we've been promoting it for probably 2 years now, and we're still waiting for it to take off.
Mm-hmm. And let's talk now about the drain water heat recovery system, because for many companies, I'm sure, or building owners, that's also not familiar.
Right.
So can you talk a little bit first about how it works and what kind of advantages you see from it?
Sure. Well, how it works. So it's basically a copper heat exchanger. It's very simple, and it has even greater benefits than solar thermal. That benefit being, in solar thermal, we don't need to expend a lot of energy in order to collect energy through solar thermal. And with the copper heat exchanger for drain water recovery, we don't need to expend any energy to make that heat recovery work. So this would be very analogous to a heat recovery or energy recovery ventilator. So in its simplest form, we have a section of drain piping from showers that's copper, and then it has a copper pipe wrapped around it. So as the shower water comes down the drain, it clings to the pipe surface because of just the way pipe water goes down a drain. And then copper has just phenomenal heat transfer characteristics, and we're able to pre-temper the replacement water. So in a benefit over solar thermal that we were just, a reliability of solar thermal that doesn't occur with drain water heat recovery is that in the winter where we have that coldest makeup water temp, we're able to have the same performance or even better performance in terms of amount of BTUs that we can recover because the water's cold. So where solar thermal can't help us much with those cold winter water incoming temperatures, it can help us very well around the, across the calendar. And that includes the winter. And that heat exchanger can recover about 50% of the energy. And because we can do it year round, that savings in energy can be realized in a smaller central plant because sometimes the sun's not out. So that can help reduce the total. Solar thermal can help reduce the total annual energy expended for domestic hot water heating. But drain water can reduce the peak energy required for domestic hot water heating. And that peak can be shaved off a central plant that's there to make up the difference that solar can't take care of and drain water recovery can't take care of. So it's a double win in drain water heat recovery. There's another type of drain water heat recovery that we've implemented, which is a whole building heat exchanger. Same exact thing, copper, but we're doing it once. The sewer drain leaving the building, we're capturing energy, we're reclaiming energy there, and in some cases that has advantages. We don't have the same recovery opportunity because that water is now coming from toilet flushing, kitchen sinks, hand sinks, all uses. But
so it's not as warm.
Right, not as warm, exactly. But it's got a real advantage that we're only doing it once in the building, except instead of for each riser. So it can be more affordable.
Right, that does seem like it would be. So I guess this is really two separate questions, but what's the best, the optimal in terms of efficiency approach that you have designed and or that you have gotten a client to implement for a domestic hot water system?
Well, in our current designs, we're promoting these two approaches that we've just described. But we haven't had these implemented in large multifamily. We expect that to happen. The technologies that we have implemented for electrification have been on the other end of the conversation, which is how do we best use electricity to generate domestic hot water? And those technologies we have installations and we know how they're doing.
So do you want to talk about getting out of the ideal systems? So can you just talk about a system that you have gotten a client to implement and what advantages there were to your approach and sort of the impact on water heating energy use?
Sure.
And also you mentioned shaving the peak, and its effect on the plant. And the systems that you need, I imagine that shrinks the size of the systems that you need and maybe the storage that you need for hot water, which must be an advantage too, to take up less room in a building.
Right. And I want to introduce one other strategy that we are incorporating with success. And that is that when we were using natural gas primarily for domestic hot water heating, we could buy a lot of boiler for not a lot of money. And the boilers were relatively compact. They didn't take up much space. So there wasn't much incentive to really nail down exactly how much domestic hot water we needed and how quickly we needed it. So those systems tend to be oversized and they tended to use basis for design or calculating the domestic hot water load that was too conservative, but it was the industry standard. So what we've done, and this is very appealing to me because we're getting after the load side, and just like with enclosures, by making the enclosure really great, and then recognizing that that reduced heating load should be responded to with a very small capacity heating system, because that's all that's required. So what we've done on projects successfully is we have measured actual domestic hot water use. And not surprising, it's much less than what we've ordinarily thought it was as an industry. So we're able to reduce the first cost associated with the plant size. So the plant size can be half of what we used to be designing. And we thought we were right sizing, but we could even cut that in half again.
Wow, that's
And
impressive.
it's a big opportunity there. But the most common system that we've been designing over the last 5 years has been a central air source heat pump domestic hot water plant. So, and that replaces a central gas-fired hot water plant. And those systems, though, they don't match well with historic systems in multifamily, in that they're more commercial, they're complex, they're using relatively untested technology, and they're expensive. The cost of air source heat pump central plant equipment is 4 times more than the same size gas plant.
That's an uphill push, I
Yeah, for
imagine.
sure. Yeah, it's pretty undesirable. So it's been really difficult for owners to stomach the increased costs. That's 4 times what they're accustomed to when they were doing the same with gas. And then on the operating cost side, the cost of, here's something that really complicates the math and the decision making, is that in different parts of the country, natural gas costs, it varies by location. Same with electricity. And so you have to look at the cost of electricity and the cost of gas where you are to understand the ramifications of electrification. And in Massachusetts, we pay close attention to the cost of natural gas versus electricity, and we've done so for many, many years. And for many years, I'm talking about 20 years ago, that difference was about a factor of 3. Electricity was 3 times more than natural gas. And currently it's over 5.
Wow.
And there was a reason for a difference of 3. It had to do with how much energy was required to make electricity, the efficiency of the electric utility plant. And so oil, coal, gas, they were primarily the sources. And that resulted in electricity being 3 times more than the source, roughly.
Right.
And so there's that delta of over 5 has it's not as simple, as why it's gone in that direction. And it's also, I think it's just like the markets in general, it's impossible to predict, in my experience, what that's going to be moving forward. So it's a major thing to consider around this issue in promoting it and helping owners accurately understand what their operating costs are going to be. And there's a real need to improve that for owners.
In multifamily buildings, is it possible to heat the water during off-peak hours and accrue some savings there? Or does that require that you have excessively large storage tanks that nobody would find acceptable?
Yeah, so thank you for raising that, because that's another variable to consider. In some parts of the country, there's a big variation in what energy costs, depending, especially, electricity, especially when you use it. And we don't see that as much in Massachusetts as other parts of the country. But you also raised something else, which is storage. Storage, intuitively, this is my experience, intuitively, it seems like it should be affordable, but it's not. Storage is counterintuitively more expensive. If the storage is on the ground in the basement or on the slab, that's better. If it's high in the building, unfortunately, water weighs a lot, so you have structural implications of storage. And then just the storage vessel itself, over a certain size, it has to be an ASME rated pressure vessel and things of that nature. Not always, but usually. And so there's costs there. In general, I was talking about gas systems, and I mentioned that the boilers or the heaters can be compact and can have a lot of muscle. So you tend to have high recovery, low storage systems because that's economically desirable. With electrification of domestic hot water, when we're using a compressor to extract heat from the ambient air to heat the water, that's a low recovery system. So we need more storage. So we're working really hard on understanding the cost of storage and arriving at solutions that are optimized. But the electrified systems tend to be lower recovery, and that dictates more storage. And that's when understanding what your actual need is very important. So you're not recovering or storing more than you need to.
That makes sense. So it sounds like you really have a difficulty in making a case for electrification of domestic hot water, but you are doing it sometimes. What is it that will convince the client to go there? Is it regulations they have to meet, or is it just that they want to have a lower carbon approach, or what does get them to choose?
Well, in Massachusetts, the choice is difficult. We've been concerned about the owners not having accurate information. And now what we've seen is, the bills come in and there's disappointment and surprise and frustration. And that's not good. That's something that we want to avoid. But we are getting that sort of feedback now. And there's I completely understand the exuberance of electrification and the principles behind it and the need to do it. But there's been a little bit of shortcutting the reality of the costs. And that reality requires it to be done very mindfully and optimized very carefully. But to get to your question, it's through regulation, through code, through agreeing to do it and committing to it. That's what's moving people to do it. The affordable clients are inclined to do it as part of their mission, just like we talked about previously. But we do even have affordable clients who really want to know when they absolutely have to do it, are required to do it, and when they're not required to do it, so they can at least know when they have a choice and can make a decision. They might choose to do gas for now and then and this is something that's sometimes happening by regulation or code or requirement, making it amenable to converting to electricity in the future. But mostly what we're seeing in passive house projects is, for one reason or another, a requirement for the building to be fully electrified, and that includes domestic hot water.
Great. Well, it's been really great talking with you. And I just wonder if you have any wish lists for 2026, anything on your wish list that would maybe make the whole business case for electrically produced domestic hot water easier or more cost effective. Do you have anything on your 2026 wish list?
Wow. Well, one thing that we strive for is simple solutions. because the simpler, the more likely it is to have a good outcome. And I believe that judiciously designed drain back solar thermal is desirable if done well. Drain water heat recovery is even more desirable. I love that it has an efficiency of infinity because we don't expend energy to reclaim that heat. And then doing those two really well, and then coupling them with a greater than typical storage capacity in order to take full advantage of solar thermal. And then also that accommodates a small, either compressor based, which is the same as air source heat pump, a small air source heat pump system, or even an electric resistance boiler that just has a pretty low draw. And because it's coupled with a lot of storage, can draw that electricity either off hours, like you introduced to the conversation, or just nice and easy and steady over 24 hours, and having that coupled with enough storage so that your electrical service size isn't undesirably impacted in order to do that. I think those three coupled together satisfy my keep it simple need. And so that's what I'd love to see, an owner that's game for that. It's still not quite as elegant and as simple as heating and cooling and electrification of heating, but I think it's a way of electrification that can, set a standard, and in the standard also still including, harvesting the low-hanging fruit, and then not looking to a compressor-based system to do all the heavy lifting.
Great. Well, we'll put that on your wish list.
Thank you, Mary.
And if it happens, please let us know.
Will do.
Well, it's really been great talking with you. I really appreciate you taking the time. And we look forward, by the way, you're going to be talking on a live presentation for the accelerator in January. So we'll look forward to that.
All right, that was James Petersen, and a really excellent deep dive into his practice, and also a great way to kick off Domestic Hot Water Month at Passive House Accelerator this month. Mary, can you share your kind of top takeaways?
Well, I was so impressed with the breadth of his knowledge, and have to say I'm really looking forward to his talk on Passive House Live, the Accelerator Live, because I know he's going to dive into more specifics about certain projects. And it's just wonderful to talk with somebody who has been through various approaches to domestic water heating and has such a comprehensive knowledge of different options to pursue. And it's exciting that he is reconsidering solar thermal, and he's also trying to convince clients to look at drain water heat recovery. I mean, both technologies can be, so achieve such efficiencies and savings in water heating. It's great.
Yeah, right. And then you continue combining those two with some extra storage. And I was really struck by, at the top of the interview, he talked about Passive House being this natural fit with his and his firm's technical values, and which I thought was a great term. And that they were, before Passive House was really a thing in the US, that he was, already focused on reducing heating and cooling demand and loads and especially through the enclosure. And so what was really interesting about this interview was his explanation of kind of taking some technical values and logic and around heating and cooling, and applying that to domestic hot water. And clearly there are challenges, like the air source hot water heating systems don't have the same track record that the heating and cooling systems do. And there are other challenges. The fact that electricity is 5 times more expensive than gas in Boston, which is, from Seattle. In Seattle, electricity is cheaper than gas. So it just, flips things on its head. But to hear that kind of multi-decade evolution in grappling with and working towards simplicity, which he really emphasized, I thought was really compelling.
Yeah, it's so interesting how factors like the costs in different parts of the country, the fact that they don't have pricing based on peak hours, peak use times,
Yep. Yeah.
was really surprising to me, because we've had time of use pricing in California for, I can't remember, 10, 15 years. And it's a
Yeah.
major strategy for reducing your heating, water heating load, energy use. So that was surprising.
So another dynamic that came through, and this is something that we've heard a lot about from in other interviews as well, is that, and it was a great question that you posed, was what's the difference between, or are there differences that he's seen in how affordable housing developers and market rate developers are sort of incorporating passive house or embracing passive house. And it's that, again, that mission driven element of affordable housing developers work just dovetails so nicely with passive house, and the reducing fuel poverty and providing safe, comfortable environments for people. And that with market rate developers, what he's seen is that is the adoption of passive house is more kind of being done because it's required now in Massachusetts, which I think is part of the reason that we're seeing so many big numbers there. And it was interesting to hear that he sees a similar thing going on with adoption of electrification. I don't know if you have any thoughts around that. Like it's not just passive house, but it's also electrification that feels mission aligned for affordable housing developers.
Right, exactly. Because of how climate will affect the occupants of affordable housing, and many times more so than those occupying market rate housing.
Right.
And what a great thing it is that Massachusetts is actually requiring passive house, so that all of the market is moving in that direction rather than, one segment of it.
Yeah, yeah. And I guess another piece of this that, I mean, I think was, touched on in the conversation, but deserves some highlighting, is how important efficiency becomes when you're dealing with when you want to electrify, but you're in an environment where electricity is multiple times more expensive than gas. It just becomes such an important tool to make electrification even possible for many
Right.
projects.
And the importance of accurate data, of course, just
Hmm.
to be able to right size your equipment because you actually know what your needs are. That was great.
Right. Yeah, absolutely. Well, is there anything else you want to add before we share some things that are coming up here?
No, only that I hope that his 2026 wish list gets
Yeah,
implemented this year.
that's right. Well, it was a fantastic interview, so thank you for sharing it with us, and I really enjoyed it. And I just a few weeks ago, I got to be in Boston and rub shoulders with James and other leaders there, and it's just so cool what's happening there. And you opened up the conversation with the 69 passive house projects, the 5,000 units. It's just these numbers are becoming really significant, which is great to see in this moment for sure.
Absolutely.
So I mentioned that January is Domestic Hot Water Month at Passive House Accelerator, and we have a number of cool presentations on tap for that, so to speak, in this month. But this week at Passive House Accelerator Live on January 7th, I get a chance to speak. I'll be doing a reprise and kind of adaptation of the keynote that I shared at Passive House Massachusetts 2025 Passive House Symposium, and it is about about kind of this messy middle that we find ourselves in, with really frustrating and damaging policy setbacks on the one hand, and also some, really astonishing clean energy success that we've seen globally, that, the kinds of progress that we wouldn't really have deemed possible just a few years ago. So we're in this messy middle, and, where do buildings sit in all of that, and how can we chart our next steps as practitioners and people who are concerned about building decarbonization in all of that. So I'm going to be sharing my thoughts about that. So I hope you'll join us for Passive House Accelerator Live on January 7th. We also have, you mentioned that, Mary, that James is joining us again at Passive House Accelerator. He'll be presenting a live on January 14th. We also then will have James do an Ask Me Anything Friday in the Reimagine Buildings Collective. So if you want to, on January 23rd, so if you want to dive deeper with James and ask your burning questions about domestic hot water and passive house practice, please join us for that. So in the Reimagine Buildings Collective, our theme is the next step. And so we have all sorts of programming that is focused on the next step, helping us chart our next steps in practice, including this week. We have an AMA Friday with Ask Me Anything Friday with Skylar Swinford that will focus on clean energy and buildings. Then we're joined for a Reimagine special with Carmel Pratt, who has taken on the executive director role at New York Passive House. And we also have a couple of meetups of members who are going to be working as peers to support one another as we chart the work that we want to do in 2026. So lots of cool stuff happening in the collective and on the accelerator. Again, Mary, thank you so much for bringing this interview to us today. And thank you, everyone, for listening to the Passive House podcast.